All right, page 715. Let's see, 3, 25, 19, and we got arcs and chords. All right, theorem 10.2 says, in the same circle, or congruent circles. In the same or congruent circles, two minor arcs are congruent if their corresponding chords are congruent. Okay, so here's what that looks like in a couple different pictures. Let's go with two circles. And we're going to say the circles are congruent. So if you've got a chord in the circle on the left, and then you've got a chord in the circle on the right, okay? We'll call the circle on the left, we'll call it circle A, circle on the right, circle B. The chord on the left is CD, and the chord on the right is EF. If circle A is congruent to circle B, and this chord on the left is congruent to the chord on the right, what that means is that arc CD, okay, would be congruent to arc EF. If the circles are congruent and the chords are congruent, then the arcs are congruent. Okay? So if you were told that this arc is 60 degrees and you were asked to find the value of x, alright, what would x be equal to? It'd be equal to 60 degrees. Good. Okay? If the chords are the same, then the corresponding arcs are the same. And vice versa. Okay? If you got two circles, and the circles are congruent to each other, and the two arcs are the same, then the corresponding chords are going to be the same as well. That make sense? Good. So take a look at the top of page 716. And on the top of page 716, it says use congruent arcs to find chord lengths. So you've got a circle on the left and a circle on the right. And let's assume that they're congruent. You've got a chord in this circle on the left and a chord in the circle on the right. And here's what you're told. You're told that these arcs, that the corresponding arcs are congruent to each other. And that segment MN is 2x plus 1. And segment PQ, or chord PQ, is 3x minus 7. Find P to Q. So you've got to find PQ. Alright, so corresponding chords are congruent to each other. So what that means is that your 2x plus 1 is equal to the 3x minus 7. The chords are going to be congruent as well. So if you subtract 2x from each side, then 1 is going to be equal to x minus 7. And if you add 7 to each side, then 8 is equal to x. Now, the question wasn't to find the value of x, though. It was to find p to q. So if you go back to p to q, which is equal to, find pq, so that's 3x minus 7, and you substitute the 8. So you take 3 times 8 minus 7. So p to q would be equal to 24 minus 7. And 24 minus 7 is equal to 17. So P to Q equals 17. Look at the example just below that, the guided practice. Now you've got one circle. And in that one circle you've got 2 chords. And the corresponding arcs are congruent to each other. So this arc is congruent to this arc. You're told that chord RS is 5x minus 9. And arc TV is 2x plus 3. And you're asked to find R to S. Alright, so again, if these corresponding chords are congruent to each other, the corresponding arcs are congruent, then the chords are congruent. So your 5x minus 9 is equal to the 2x plus 3. You can subtract 2x from each side. Five x minus 2x is, so 3x minus 9 is equal to 3. You can add 9 to each side. So 3x would equal 12. And then you can divide both sides by 3. X would be equal to 4. Alright, but again, you weren't asked to find the value of x, you're asked to find R to S. So R to S is equal to 5x minus 9, so you replace the x with the 4. Five times 4, you got 20 minus 9, and 20 minus 9 is 11. So chord RS is equal to 11. Anybody got any questions on that? Alright, let's take a look at a question like this one. In this circle, you've got this picture here. You're told that these 2 chords are congruent to each other. You're told that arc RS is x degrees. And you're given this angle measure right here that's 89 degrees. and you're asked to find the value of x. So look, this arc, RS, is going to be the same as arc ST, because these chords are the same. Alright? So this 89 degrees is a central angle. And since this angle right here is 89 degrees, then this arc S to T is also 89 degrees. So what's the value of x equal to? 89 degrees, good. Okay? So they gave you this arc measure, they just gave it to you indirectly. They gave it to you as a central angle. So remember that central angles are congruent to their intercepted arcs. And intercepted arcs are congruent to their central angles. Everybody good with that one? Alright, take a look at this one. Alright, in this picture you are told that chord HG is equal to 7 and chord GF is equal to 7, and that this arc F to H is 200 degrees, and you're asked to find this arc right here, H to G. Okay? So here's what you're dealing with. If these two chords are the same, if F to G is the same as G to H, then they're congruent to each other. If those two chords are congruent to each other, then arc F to G is also equal to x degrees. Okay? So what do all of these arcs in this picture have to add up to? It's a circle. They got to add up to 360, don't they? So you've got an x plus an x plus 200. So you've got 2x plus 200. That has to equal 360. Okay? So if you subtract 200 from each side, then 2x is equal to 160. And if you divide both sides by 2, then x is equal to 80. Anybody have any questions on any of those types of problems? Okay, your assignment for today is on page 718. One through 3, and then over on the next page, 7 through 12. Make sure you show all your work for any problem that needs work to be shown. And do those on a separate piece of paper, please, not on the back of your notes.